In this video we're going to look at simplifying surds, but before we start simplifying them, let's just remind ourselves what they are. Surds are basically nasty square roots. If you have the square root of 10, I'll call that a nasty square root because if you do it on a calculator, square root of 10, and some calculators you have to press the SD button, it's a nasty decimal. Therefore that is a surd. Whereas if I did the square root of 16, well, the square root of 16 is 4 because 4 times 4 is 16. So that's not a surd because root of 16 is just 4 and 4 is an integer, a whole number. So this one is a surd over here, this one here is not. The basic thing is surds are nasty square roots which come out to be nasty decimals. So we're going to look at simplifying some surds. The first one we're going to look at is simplifying root 40. And you might say, well, what are we trying to do in simplifying surds? What you're trying to do is get the smallest number possible inside the square root sign. Any other numbers outside the square root sign, that's fine. And the way to do it is to try and spot what two numbers multiply together to give you 40. Okay, so there's 1 times 40, 2 times 20, 5 times 8, 4 times 10. There are various different numbers that multiply together to give you 40, and you're looking for a pair of numbers where one of them is a square number. And if I go for 4 times by 10, 4 is a square number. And that's the one I'm going to use. You're always looking for a pair of numbers which multiply together to give you the number inside the square root sign when one of them is a square number. So the square root of 40 is the square root of that sum. And I write that like that. That sum inside the square root sign. And then what you can do is this. If you have the square root of two numbers which are multiplied together, and it also works if they're divided, it does not work if you're adding or taking away. But if you're multiplying together, you can say it's the square root of the first number times by the square root of the second number. Now I'll emphasize again, you can only do this if it's a times sign or a divide sign. You cannot do that if it's adding or taking. Now hang on a minute, the square root of 4, that's just 2, because 2 times 2 is 4. Square root of 10, well, we'll leave that there. Now because there's no square number that goes into 10, I cannot simplify that surd. Because the square numbers are 1, well that doesn't actually help us. 4 doesn't go into 10, 9 doesn't go into 10. The next square number is bigger than 10, so that doesn't help us. So root 40 can be simplified to 2 root 10. And whilst it looks more complicated, in mathematical terms it's been simplified because the number inside the square root is smaller. So we're going to look at some more. Number 2, we'll have a look at root 50. So the first thing to do is to think what numbers multiply together to give me 50. And can I come up with any pair of numbers that multiply together where one of them is a square number? Well, hopefully you'll come up with 25 times by 2. 25 times by 2 is the same as 50. So that means root 50 is the same as the square root of the sum, 25 times by 2. And because there's a multiplying sign in here, we can say that's the same as root 25 times by square root of 2. The square root of 25 is 5. I'll leave the root 2 there. So root 50 is the same as 5 root 2. I've simplified that surd because the number in the square root sign is smaller than it was at the beginning of the question. As well as doing this to individual surds, sometimes you can have questions which involve more than one. The third one we're going to look at now is to simplify root 48 plus root 27. So you may have a sum here involving square roots, involving surds. 48. Well, you can get 48 from 6 times by 8, from 2 times by 24. We're really looking for one which has got a square number in it. So it's useful to just think square numbers of your times table, so your 9 times table, 9, 18, 27, 36, 45, 54, that hasn't helped. Next square number 16, so we can do 16, 32, 48, 64, 48. So 16 times by 3 is 48. So I can rewrite my 48 like that. How about 27? 27 is 9 times by 3. So root of 27 I can write like that, and these two sums are being added together. Root 16 times root 3, using the same trick as we did up here, splitting them up, that's the same as root 16 times by root 3. And over here, root 9 times 3 is the same as the square root of 9 times the square root of 3, and I'm adding those bits together. The square root of 16 is just 4. So this left-hand side is the same as 4 lots of root 3. On the right of my plus, root 9 is 3. So I've got 3 lots of root 3. So I've got 4 lots of root 3 plus 3 lots of root 3. It probably won't surprise you to realise that's 7 lots of root 3. If you think of 4 somethings plus 3 are the same thing, it's 7 of those things. So 4 root 3 plus 3 root 3 is 7 root 3. And that will be the answer to that question. We have added those two surds together and we've got our answer written down as simply as we can. That means with the smallest number inside the square root. If we look at another example, we'll look at root 45 plus root 63. We'll start off by doing the same thing. Try and spot what numbers go into 45. What we can get to times together to get 45 with one of them a square number. 45 is 9 times by 5. 9 is a square root, so that will be helpful. 63 is 9 times by 7. 9 is a square number, that will be useful, and we're adding those together. Using the splitting up trick, because we're timesing inside the square root, that's the square root of 9 times the square root of 5. Over here, it's the square root of 9 times the square root of 7, and those bits are being added together. Square root of 9 is just 3, so it's 3 root 5, and over here, the square root of 9, that's also 3, so I've got 3 root 7. So I've got 3 root 5 plus 3 root 7. If you wanted, you could take 3 out as a factor. It appears in both bits, so you could have 3 out as a factor, and then have a set of brackets. The 3 is being times by root 5, then you're adding on the 3 being times by root 7. So you could have your answer like that, 3 lots of root 5 plus root 7. And in these questions where you're simplifying surds, you haven't got to work it out as a decimal, they want you to leave it just like that. There'll be some more examples in part 2 of this video.